Good afternoon. My name is Don Human. I'm the director of the Center for Ethics and Human Values, the organization that's putting on today's event. This is part of what we call the COMPAS program. COMPAS is an acronym for Conversations on Morality, Politics, and Society. We describe COMPAS as a year-long, university-wide conversation on some topic that raises foundational moral questions, but requires input from a wide variety of disciplines to address it in an intelligent way. This year's COMPAS theme is religion, but we're not actually viewing today's event as a part of the religion compass, although there are some people who seem to look at advanced automation and machine learning and so forth with an almost religious fervor. Some people seeing it as a savior and others seeing it as a coming destroyer, I think. Last year's compass theme was on inequality, and we actually were hoping to get our speaker here last year to be a part of the inequality compass. Because there are obvious implications of today's topic for issues of material inequality. I think I fact-checked this much with our speaker on the way in, that over the past 30 or so years, the increase in productivity in the U.S. has been rather dramatic, but the actual wages of workers has been pretty much flat. And one facet of that has to do with automation, the ways in which we've automated a lot of work. But we're actually viewing it as a sneak peek, an early taste of next year's compass. The theme next year will be on technology. We'll be exploring a lot of the ways in which technologies are changing the ways in which we live, the ways in which we interact with one another. And so this is a particularly apt topic to take up in connection with next year's technology compass. So for a very long time, there have been fears that machines are going to take our jobs, that we're not going to have any work to do with new machines, and for the most part, those fears have proven to be overblown, although there have been certainly dislocations and problems for individual workers and for individual communities overall. Those most dire predictions have not panned out, but there's also something different that's happening now. We're not just magnifying human muscle or speeding up productivity. We're actually making machines that take over human judgment and decision making, and so it could really be that things are a bit different now. To help us think through these questions, to address these questions, we have Professor Anna Salomons, who is the Chair of Employment and Inequality at the, I'm going to try it, Utrecht University in the Netherlands. She's currently visiting at Boston University. I should also point out that today's, while the Center for Ethics and Human Values is handling the arrangements for today's talk, it's made possible through the generosity of Daryl Dreyer, who has funded the Dreyer Chair in Political Communication and Policy Thinking, a chair that's currently held by Professor Gregory Caldera, who's sitting right here in the second row here. So we have Mr. Dreyer and Professor Caldera to thank for today's event. So with that, let me introduce Anna Salomons. I think you're going to enjoy this.
Thank you so much for that incredibly kind introduction and the invitation to be here. I'm thrilled to be here and talk to you a little bit about this topic that I've worked on, which is, does technology threaten employment? Or to put it a bit more provocatively, are we entering sort of the time of a robotic apocalypse, or Robocalypse, right, where we're all becoming obsolete as humans and we're being sort of increasingly replaced, right, by these smart, incredible machines which have advancing capabilities that are just encroaching on what humans can do. So this is by no means a new concern, as Don already alluded to. During the first Industrial Revolution, the Luddites, who were skilled weavers, were protesting the arrival of weaving equipment. There's been a number of US political initiatives trying to think about this concern. Nobel Prize winner Wassily Leontief famously remarked that the role of workers will diminish, just like the role of horses in our economy has diminished. And I'll come back to that analogy later. And also at present, we're really living in a sort of time of automation anxiety, if you will. And just a quick sort of illustration of that is this cover of The Economist, which depicts technology as a sort of hurricane tearing through an office space, destroying all jobs in sight. Right? Some other evidence, this is from Europe, where I happen to be from, which is the survey evidence from 2017 on 28 European countries, representative of the citizens of these countries, where the question posed to them was, when it comes to robots and AI, so artificial intelligence, to what extent do you agree with this statement, more jobs disappear than are created? And an overwhelming majority of respondents actually either totally or tend to agree with this statement, which is, I would say, a lot. So what are we really talking about here? We're talking about the current and ongoing digital revolution that we all live in. That started around the 1980s, with computing, ICT technologies, but also robotics and other types of advances like in machine learning, which is a type of artificial intelligence. And this really increasing span of these machine capabilities has people worried that this will encroach on human tasks, right? And just to give a few ideas of what these amazing technologies can do, this is a very standard industrial robot, right, that we've probably all seen before. It's sort of manufacturing cars, doing so pretty autonomously. Newer types of robots are even more flexible, smaller, cheaper, can work together also with humans. So this is a robotic arm that collaborates with humans. It's known as a cobot or collaborative robot. Another type of cobot is Baxter, which is also used in manufacturing, small-scale manufacturing, which can be taught movements by humans and then repeat them, so it's very flexible. There's been this sort of hype about dogs opening doors that people are really excited about, so chivalry's not dead, which is good. There's these sort of warehouse applications where human pickers just in these warehouses stay in one place, and these robots scoot out and get the shelves to the human picker, so that automates a lot of the work that used to be done in logistics. There's a lot of healthcare applications as well. So this is a surgery robot assisting surgeons in very small, precise movements on patients. There's the Robo-Bear, which helps move people from one place to another in healthcare. There's the robotic apothecary, or as I like to call it, the Robothecary, which prescribes and produces and dispenses medicine. And these sort of robotic adoption of these technologies has increased over time. So this is data from the International Federation of Robotics from a research paper by these authors, showing that even though robots are still a relatively small phenomenon, they have been growing at a very fast pace. So in about 1993, when these data start, there were about, let's say, half a robot per 1,000 workers, and that's since increased to about 2.5 per 1,000 workers in Europe, and a bit less so, but still a positive trend in the US to about 1.5 robots per 10,000 workers. Now, of course, robots is sort of one of those technologies that it's easy to get pictures of, but there are many other machine advances that are just embedded in software, and machine learning is sort of one example of that. That includes things like image recognition, voice recognition, pattern recognition that can be used across a very wide range of tasks to do or complement or replace what humans are doing. And one very famous recent sort of achievement there was when Google's DeepMind AlphaGo algorithm beat the human Go champion. And the New York Times article reporting on that, so this was in May last year, I think. The first line of that article was, "It isn't looking good for humanity." So this sort of gives you an idea of the sort of general response. And there are other examples that people often allude to, like IBM's computer beating human Jeopardy champions, which is sort of a remarkable feat. But since then, this computer which is called Watson, has been also used in business applications and in healthcare and all sorts of other impressive feats. So that's really the concern, right? So the concern is these expanding capabilities are encroaching on what humans can do and are threatening workers in that way. So that's really the question I want to talk about. I want to talk about, does technological progress actually reduce labor demand? And there are sort of distinct dimensions of that I think are important. So firstly, what's happening just to the number of jobs, right? So just absolute employment or hours worked, whichever way you want to define it, is that declining? So is absolute labor demand declining as a result of automation? Or to put that another way, are humans becoming obsolete? So we can call that the Robocalypse scenario, right? The robotic apocalypse, we're becoming irrelevant in the labor market. The second type of thing related to labor demand is more a relative labor demand concern, which is what's happening to wage inequality. So is the demand for some types of workers or some types of jobs increasing faster than others, and is that creating disparities in the labor market? That's the second dimension. So really this boils down to the question, do all workers benefit equally from these new technologies? And then thirdly, what's happening to labor share in national income? So to the extent that these technologies make us more productive, make us richer, to what extent does labor actually share in those gains, and is that changing over time? Okay? All right. So the analogy I want to be using throughout this discussion is, to what extent will people go the way of horses? And that analogy originates from Vasily Leontiev, as I already said. So I'll just quickly read out the the sort of original quote, which is saying, computers and robots replace humans in the exercise of mental functions in the same way as mechanical power replaces them in the performance of physical tasks. As time goes on, more and more complex mental functions will be performed by machines. Any worker who now performs his task by following specific instructions can, in principle, be replaced by a machine. This means that the role of humans as the most important factor of production is bound to diminish, in the same way that the role of horses in agricultural production was first diminished and then eliminated by the introduction of tractors. And that's a sort of 1983 reference, which I think most of you may be a bit dated. So I have a more recent sort of incarnation of this. I'm sorry, how do I do this again?
Sorry, Alt-Tab.
Thank you. Oh, there we go. Which makes this argument.
Imagine a pair of horses in the early 1900s talking about technology. One worries all these new mechanical muscles will make horses unnecessary. The other reminds him that everything so far has made their lives easier. Remember all that farm work? Remember running from coast to coast delivering mail? Remember riding into battle? All terrible. These new city jobs are pretty cushy, and with so many humans in the cities, there will be more jobs for horses than ever. Even if this car thingy takes off, you might say, there will be new jobs for horses we can't imagine. But you, dear viewer, from beyond 2000, know what happened. There are still working horses, but nothing like before. The horse population peaked in 1915. From that point on, it was nothing but down. There isn't a rule of economics that says better technology makes more better jobs for horses. It sounds shockingly dumb to even say that out loud, but swap horses for humans and suddenly people think it sounds about right.
So that's the argument, right? So this is coming from a YouTube video that was going pretty viral a couple of years ago called Humans Need Not Apply. So the argument is really, people are like horses. Horses became obsolete as a result of new technologies. The same is going to happen to us, right? So how appropriate is that reasoning, right? Let's first see what actually happened to horses. So we have a pretty good idea, but let's look at some data. So from a horse perspective, how did technology change? Well, there have been, of course, historically some horse complementing technologies, meaning horses became more productive as a result of these technologies, but they weren't replaced. And examples of that would be carriages, right, for person transport, or these horse-drawn, what would you call them, wagons, right, for goods transport. Those would just complement horses. They are not replaced by that. They just work together with that technology. However, we also know then some newer vintages of person and goods transportation were much more horse replacing, right? So the horses were automated by cars and trucks. Now, what happened as a result to horse employment? Let's look at what happened to the production of these technologies first. So here we have, on the vertical axis, production in thousands for, on the one hand, horse-drawn carriages, and then on the other hand, cars, right? So the horse complementary technology and the horse automating, replacing technology. So clearly, the one that won out were cars, right? Same for the farm wagons and the trucks. So farm wagons, the horse complementary technology kind of petered out over time, whereas, starting in 1900 here in these data, the trucks were rising. Now, what happened to horses? Let's look at that horse race. Horses versus the horse replacing technologies. Here again, I have these technologies which are increasing over time on the left axis. Then what happened to the horse population in the US, which is represented here, horses and mules, it really was nothing but down, like the video says, right? Now, technically, we of course don't have horse employment numbers, but the thing with horses is we sort of breed them as we need them, so we can look at the population and call that horse employment, right? So horse employment went down. Horses became obsolete as a result of these technologies. That's clear, so that's established. Are there examples of human jobs becoming similarly extinct from automation? Sure, right? So here's one, elevator operators. Here's another one, lantern lighters. Here's another one, bowling pin setters. I'm not sure bowling is still a thing either, but you guys can tell me that. Switchboard operators, right? Knocker uppers, anyone ever heard of this? So this is a job in England and Ireland during sort of the start of the Industrial Revolution, when alarm clocks were prohibitively expensive and or unreliable. These people would go knock on people's doors or windows to wake them up. Human alarm clocks, right? Been totally automated. Something that's been nearly automated, I guess, milkmen, right? So I think in about 50 years ago, some 30% of milk was still delivered at home. Now that's dwindled. In 2005, which was the last year the US Department of Agriculture collected data on this, it's about 0.3%, so near job extinction. By the way, in Europe, we call these knocker uppers, but that's probably a cultural thing. But what happened to people, right? So we have these examples of jobs being automated, completely automated away. But if we look at the graph of human employment to population, so human employment rates over time, we do not see that precipitous decline that we saw for horses at all. In fact, we see, if anything, an increase, slightly a decrease at the more recent years, but definitely no sort of all nothing but down story there to be found, right? So how can we reconcile that with the fact that over this period, from 1890 to 2016, there's certainly been a lot of technological progress and a lot of automation taking place. So how do we think about that, right? So I think the way to think about that is that humans are not horses. And there are three main reasons for that, I think, which can help us think about how technology actually impacts labor demand. And I'll point out, why these things, I think these things are important, and also the sort of challenges that arise when you look at comparing horses versus humans in this way. So, and those are, just very succinctly, horses are one-trick ponies, horses don't have income, and horses don't vote. So I'll go over those in turn. So firstly, horses are one-trick ponies. What do I mean by that? Well, horses can only do a fixed set of tasks, right? They can pull things, they can kind of walk about, that's what they do. If there's automation of those tasks, there's really nowhere for them to go. On the other hand, humans are very adaptable. And that's for two main reasons. We can learn new tasks, right, which is through both formal education, also through on-the-job learning, learning by doing, investing in skills that are complementary technology. So we, let's say, take refuge in things that are not yet automated, and then the new technologies actually complement us, make us more productive, act like those horse-drawn carriages instead of those cars, right? That's the first reason. So we can learn new tasks. The second thing is we're also creative. We come up with new tasks. We come up with new goods, new services, which then need labor to produce, right? So those two things are related to, in my view, the idea that humans are not one-trick ponies. We can do new things. We can invent new things. And as a result, on the whole, technology has been much more complementary to humans than it has been to horses. Okay, so let me show you some evidence on those two pieces. So that's the good news, right? We're flexible, we're adaptable. One very clear piece of evidence for that is if you look at educational attainment across the US for a very long period of time, so starting in 1870 up to, I'm sorry, these are cohorts that were born in 1870 up to cohorts that were born in 1975. On the vertical axis is the years of schooling they've attained at age 35, right? And that's really increased spectacularly. So around 1880, the average 35-year-old had about 7 years of education, and the cohort born in 1975 had about 14 years of education at age 35. So that's a massive increase. If you think about, if I were to replace everyone in this audience by their great, I don't know how many greats, but many greats, grandfather or grandmother, right? They wouldn't really be able to perform the jobs that you are currently performing or will be performing very soon when you graduate, right? So this sort of thought experiment shows that people have very much learned how to do new things. Whereas if you did that same thought experiment for horses, obviously a horse born in 1880 can pull a cart just as well as a horse born in 1980, right? There's not really any change there. Whereas for humans there has been, and one reason is this incredible accumulation of human capital. And this, of course, is something we can measure, right? So we can easily measure this in statistics, but there are many other ways that people can adjust. I think we all sort of see that people can learn. And actually, also research suggests that having more educational attainment also makes you more flexible in adjusting to new job tasks, even in things that you weren't technically trained for, right? So this is kind of also an underlying statistic for that. Now, this is not unique to the US, of course, so here's some evidence from a bunch of other countries as well, so some OECD countries. And on average, this is looking at tertiary education. If you look at the average here, this is telling you that if you compare today's 50 to 65-year-olds to today's 25 to 34-year-olds, there's almost a doubling in the attainment of tertiary education between those two generations, essentially, which is really massive. Okay. Now, and as I said, formal education is not the only way we learn. There's also on-the-job training, learning by doing, et cetera. But this is just to show, to document this sort of incredible ability to adapt, which has helped us not lose the race to the machine, right? If we had stayed at this type of level of skill, certainly we would have gone the way of horses in the sense that there wouldn't really be all that much for us to do in that sense anymore. Okay, that's the first bit, right? We adjust, we are able to learn new things. The second part is we also create new things, come up with new ideas, and that also acts as a counterbalancing force against outright replacement by technology. And there's historical evidence on this, so from 19th century Britain, from early 20th century America, of new jobs arising as old ones were replaced. But also more recently, so there's been some statistics collated by Jeffrey Lynn showing that in 1980, around 8.5% of US workers were employed in work that didn't yet exist, or at least wasn't cataloged by statistical agencies in 1965, and similarly for the other decades. So creation of new tasks, which are labor using, is an important source also of employment growth that obviously horses don't have because they're one-trick ponies. They don't come up with new things to do. Some slightly more formal evidence of this is coming from a paper here, which is basically cataloging the share of new job titles in each occupation that emerges at the start of each decade, and then relating that to the percentage change in employment growth over that same decade, showing that these new jobs are growing faster than other jobs. So there is a significant source of employment growth coming from these new jobs, right? Okay. So that's the good news, right? We're creative, we come up with new things, and we're able to adapt to the changing demands in the labor market. What's the challenge here? Well, the challenge is really that there's been a very big increase in inequality associated with this. So if you look at the post-war period in the US and you plot real income at 3 percentiles, so the lowest percentile here is the 20th, the 50th percentile, that's the median, and the 95th percentile, so they're relatively high earners in the economy. You see that real income growth for these 3 cuts of the wage distribution was pretty much in pace up to around 1980, where there was this big divergence, where these high earners really pulled apart from the rest. And actually, as already alluded to in the introduction, the lower percentiles of the distribution were relatively flat, saw little income growth, certainly compared to the top. And there are also periods where there was absolute income declines for these groups. So that's a real challenge. And how does that relate to new technologies? Well, these new technologies have been shown to be very strongly skill biased. So they very much increase the demand for skill. This is showing the return to college relative to high school, and how that is basically increased very, very sharply since the start of the digital revolution, so since the 1980s, which can be accounted for, and economists have accounted for, by allowing for an outward shift in the demand for skill, so for allowing an increase in demand for skill, which essentially, when supply doesn't match up with it, increases this wage premium and drives the increase in inequality. Right? So not all workers have benefited similarly from these new technologies. If you're high-skilled, your wage premium has gone up a lot. If you are in the lower parts of the distribution, you've seen much less of these gains. Now, one way that further research has looked at this is looked at the sort of underlying job distribution. So which jobs are really increasing in importance in our economies and which ones are declining. And here we see a phenomenon that's been termed job polarization. Also, you could think of it as the barbell economy, right? The barbell economy is a bar with weight on the ends, more weight is being placed at the ends. How's that? Well, if you rank jobs by their wage or their skill level, which are extremely correlated, you get, the low-paying jobs are things like personal services, food, cleaning services, some protective service. Then in the middle, you have some manufacturing work, operators, production work, as well as some office work, office support, administrative support, bookkeeping, etc., sales, and then your high-skilled, high-paid jobs, which are managers, professionals, and technicians. And if you then plot the change in employment, growth in employment, over the 80s, 90s, 2000s, and then after the crisis, you see that there's been a decline in the middle, right? So the growth, the employment growth, has been taking place in these high-paid, high-skilled jobs, on the one hand, managerial, professional, but also low-paid, low-skilled jobs at the expense of this middle. So there's been this hollowing out phenomenon, this barbell economy, with more weights at the end and less in the middle. And the reason this is linked to technology, researchers have argued, is because if you think about what can be automated, so if you think of the job as a collection of tasks that you have to do, the things that can be automated are basically things you can embed in software, right? And if you've written a program, you know that software is really, especially so far, mostly a set of if-then statements. So, if this happens to that, if this happens to that, which means if you can summarize a task in a set of very predictable lines of code, right, then you can automate it. You can embed it in software. You can make it codifiable. And it turns out that those tasks are mostly concentrated in the middle of the wage distribution. So, for example, a lot of production work, right, as we already saw with these industrial robots, but also, say, quite complicated from a human perspective, calculations made by, say, bookkeepers, right, or things done by secretaries or office support. So those things are relatively easy to do for the current state of digital technology, even if they're not necessarily the easiest for humans. On the other hand, on the other side of the spectrum, these high-paid, high-skilled jobs require a lot of problem-solving, abstract thinking, cognitive skills, which are as yet difficult to automate, and actually have mostly been complemented by these technologies: increased information, increased computing power, etc. So that's led to an increase in labor demand there. But also at this lower end, so things that are relatively easy for humans, like babysitting. Maybe not a great example, cleaning a room or serving in a restaurant, something like that is incredibly hard to program because it's very unpredictable. You have different environments, so it's very hard to write a precise set of if-then statements that would allow you to precisely replicate that job every single time, right? Say, getting a haircut. Everyone's hair is different, everyone's head is different. There's also some interpersonal skills there, right? So these sorts of jobs have been as yet challenging to automate. So there's also been an increase in the demand there. The problem is that these skills are very abundant among humans, right? So there's not really any wage return coming for that. So what you get in this barbell economy is an incredible sort of rise in the demand for these skills, which are scarce, which means we get a big skill premium and increase in inequality, especially since at the bottom, people are pushed from the middle towards the bottom, increasing the supply, right? And really, there's not really, from a human perspective, all that much skill involved in these jobs, even if they're difficult to automate. So there's not the same type of wage return coming there. And that's underlying part of this increasing inequality that we also see as a result of automation. In work looking at Europe, we see similar phenomena. So this is data for the US. This is for 16 European economies over up to 2010, where these negative bars here are middling jobs, so middle-paid jobs, middle-skilled jobs, and here these positive bars are high-paid and low-skilled jobs. So very similar barbell economy phenomenon occurring across these countries, which is what you would expect if they have access to similar technology, of course. And that's what this work also finds. Now, this sort of, as a final sort of illustration of this barbell economy, there have been people looking at what's happening to the US middle class. Now, the middle class is one of those kind of hairy things that people like to define differently, and it's sort of a bit tricky, but one definition here used by the Pew Research Center is middle income households. So we're looking at household income now. We can define those as incomes that are 2/3 to double that of the US median household income. Okay, so of course if there's an increase in inequality, that would pull apart that distribution, so that would tend to reduce the people who fall in that middle class bin, right? So the support in the middle is reduced, the barbell economy means more weight is added at the ends. And that's what you see. So starting in 1971, 61% fell in that middle class category, and that's decreased to about 50% in 2015, with more being both in this upper class, but also in this lower class, right? So that's really a challenge coming from this great adaptation that we've all made to the new changing demands for skill in the labor market resulting from these technologies, is that not everyone has equally benefited from that development. Okay, so just to summarize, right, the first sort of crucial difference between horses and humans is that humans are not one-trick ponies. We can adapt to new things. We can be creative and come up with new things to do, which again use labor, create employment. But that underlying skill bias that technology has increased employment and created this barbell economy or job polarization in what the distribution of jobs looks like. Okay, second point. Horses don't have income. So why does this matter? Well, if you think about what happens to labor demand, if you think about what happens when we become more productive, if we have a labor-saving technology, let's say we automate part of the jobs, right? Part of what humans do, that means we need less labor to produce one unit of something, some good, some service. But of course, because we are the beneficiaries of that productivity increase, right? Humans own the capital and we earn wage income, we will also demand more things, right? So there will be a demand response. And as a result, product demand increases means also, of course, labor demand will increase, since labor demand derives from product demand. So you need to produce more stuff, you need more labor to do it, even if you need less labor to produce only one unit of output, right? And that operates sort of on two levels. Firstly, within the goods, services, or industries that are becoming more productive. So if you're becoming more productive at producing something, you'll tend to want to consume more of it if it's a normal good, which would be a demand response, right? Which would all else equal increase labor demand. But also, if your goods and services in your consumption basket are becoming cheaper, that frees up income that you'll use on everything in the economy, right? That you can spend on all goods and services, which will create employment across the economy. So those two demand effects, there's also evidence for, and that's really the good news here. So this is an example from Jim Besson, who looked at what happened to bank tellers when ATMs were introduced. So prior to the introduction of ATMs, bank tellers were, dispensing cash. Bank tellers then, as the ATMs were introduced, so bank tellers really didn't need to dispense cash anymore, not as much anymore, and people predicted that this would be the end of the bank teller job, right? It's being automated. Why does it still exist? But that's not what you see over time. So if you look at the number of ATMs installed, actually teller employment went up a little bit as well, or stayed at the very least stable over this period. Now, why is that the case? Well, Professor Besson estimates that prior to the introduction of ATMs, it took about 21 tellers to operate one bank branch, whereas after the introduction of ATMs, this drops to about 13. So it became much cheaper to operate a branch, right? So you could have many more branches and provide the services at lower prices, which induces a demand response. So, and as a result, actually the total number of branches increased and the total labor demand increased as well, even if we needed fewer people per branch. Now, of course, it's important to realize that what then these tellers did may have changed as well, right? So it's sort of relates to the first point that these tellers probably weren't one-trick ponies, and what they ended up doing was more client management and sort of required different skills, more interpersonal skills. But the point is, looking at this job, even as there was very clear labor substituting automation taking place for that job, we don't see that here the employment is decreasing, even looking within that job. Now, there are many more examples of this. For example, the electronic registers, cash registers, didn't decrease cashiers. Document discovery, electronic document discovery, didn't reduce the demand for paralegals. It actually increased paralegal employment. So there are many examples of that just within any one industry where the demand response was strong enough to compensate any labor savings for producing one unit of that output, right? Now, that doesn't have to go on forever, right? If you look at very long periods of time, say this is for textiles since 1800, we do see that, throughout this period there was a lot of automation, a lot of technological progress in textiles. This initial increase in employment, which is plotted here on the vertical axis, comes from a very strong demand response that was strong enough to overcompensate any labor saving. But over time, as demand saturated and the sort of highest value usages of textile become exhausted, you can see a decline. So it's not sort of a law that within any industry that becomes more productive, employment will necessarily increase. But of course, that demand response matters. It means that automation doesn't one-to-one reduce the demand for labor, even within the places that are becoming automated, becoming more productive, right? So that's the first dimension of the demand response. The second dimension, which I mentioned, is that then you will spend more on all goods and services in the economy. So you don't just, when your banking becomes cheaper, make endless more trips to your bank. You actually, with that freed up money, buy all sorts of other goods and services, right, that you have in your basket. So this is just a very basic human sort of greed principle, right? So we get more income, we want to spend it, and that's what we do. And together with my co-author, David Otter, we have tried to estimate this type of general demand effect, economy-wide demand effect, coming from productivity growth across a set of 19 developed countries, including the US, since 1970. And what we find is there is evidence of those labor-saving effects. So it is true that if we become more automated, if we become more productive at producing things, we can see that labor is being saved on net within those industries that are advancing over long periods of time. However, the demand effects that I just mentioned, which operate economy-wide, are strong enough to more than overcompensate those negative effects that occur within the industry. So there's enough of the demand response to actually weekly increase employment on net. So these are not very big effects. This amounts to about 6% increase in employment over the 39 or so year period we consider. But this is very clearly not showing this robotic apocalypse scenario or the graph for the horses, which is precipitously went down, right? So we see, if anything, a mild increase in employment as a result of automation and technological progress. And that's coming from the fact that humans have income. Now, that's the good news. What's the challenge here is that these impacts can again be very uneven, right? So just because the total number of jobs isn't declining doesn't mean there aren't huge shifts in the types of jobs that then are in demand, right? So this is looking at a very long run story, which I'm sure you're all familiar with, which is sort of the transformation starting in 1840 up to 2010, away from agriculture towards first industry, but then also employment in industry started to decline as a share of the total employment, and towards services. So clearly there's a huge underlying transformation of the types of jobs that are available. Even if total employment isn't declining, even if humans aren't becoming obsolete, and if you're a worker who loses their job to automation, it may not be all that much consolation to you individually to say, oh, but there's other jobs coming somewhere else in the economy if you're not qualified or don't have access to these, right? So that's the underlying adjustments that are required from our economies. And that's at the sector level, that's at the occupation level. So this is what I related to the barbell economy I showed you before. So if you look at different jobs and how they've evolved over different periods, so then prior to the digital revolution, these patterns were quite different. So starting during the digital revolution, there's been, for example, a very strong negative effect for these clerical support routine office workers, where I've argued that these can be more easily substituted. But of course, also during these previous periods, there were huge adjustments, right? So away from agriculture, for example, and towards services. So these are the sort of uneven impacts that you have across jobs, and they're also uneven across space. So this is a picture showing exposure to robots across space. So basically, the automation potential of the current jobs being done in these US regions and how easily the current state of technology, robotic technology, can replace work in these regions. And although I already mentioned robots are still a pretty small phenomenon, we do see a relationship between the places that have the highest robot exposure, which is moving to the right on this graph, and employment growth. So more potential for robot automation is correlated, is associated with less growth at the regional level. Employment growth at the regional level. So some of these regions, so these regions are not impacted in the same way, right? Which from this heat map you can see, the darker the region, the more exposed. This clearly isn't all the same color, so not all regions are going to be impacted the same way. Now, as a final concern here is that it's also been documented that labor share of total income is declining, which is to say the share that income that goes to labor, the share of value added that goes to labor, was relatively stable in the US for quite a long period of time. It's actually one of the stylized facts of economic growth as economists thought of it, but then more recently has been on the decline. Now, why is that important? That's important because if you think of people having income and income increasing from productivity growth, we know now that as labor share declines, that even if productivity growth increases incomes, a declining share of that growing pie, let's say, is going to labor, right? So the extra slice going to labor is becoming smaller. Now, of course, capital is also owned by people, so it's not that that sort of income evaporates somehow, but we know that capital income is much more unevenly distributed than labor income. So that's again tending to reinforce the increase in inequality that we're already getting from these technologies. So that's the concern there. Now, that's the US. It also occurs in Germany, Japan, China, and a bunch of other countries. So it's again sort of a phenomenon that seems to be pretty pervasive and widespread. Okay, so to summarize, the second main difference between horses and humans is that unlike horses, humans have income. Why does that matter? Demand effects. So even if we really always produce the same amount of stuff, we might save a lot of labor, we'd lose a lot of jobs, but that's never happening because we see that people consume more as their income frees up. And their income frees up because we own income, right? Because we are the beneficiaries of these new technologies that allow us to be more productive. However, the downside of that is that these job losses that we do see can be concentrated in specific jobs, specific sectors, specific regions, so maybe felt very unevenly. And then on top of that, the share of labor in national income has declined, meaning that for a given amount of productivity growth, labor takes less of a cut of that. Okay, final point, difference between horses and humans is that horses don't vote. By which I just mean to say technology is not destiny, right? So horses just undergo whatever technology occurs, right? They have really no say about it, but we do, because any impacts that we feel from these new technologies are, of course, moderated through our institutions very broadly, which ultimately means our political institutions, right? What we vote into place to deal with this. And that's really, of course, a big bonus, right? So we can manage these impacts. We can, through our political systems, make these transitions easier and make sure the gains from these new technologies are more broadly shared. The other side of the coin is, though, that does require, that's not automatic in any way. So that does require political will. And we know that economic shocks can also have adverse political consequences. So there can be, it can be difficult sometimes to coordinate on that. So let's look at that. So the good news first, which is we vote. And one very prominent example of societies adjusting to the new demands coming from technology is actually the US high school movement, which started in 1910, which was a very decentralized, publicly funded effort to increase schools, to build schools. Parents sent their kids there. And as a result, between 1910 and 1940, US high school enrollment increased spectacularly from about 8% in 1910 to about 50% in 1940, which is a really incredible public, decentralized, but public effort to deal with the increasing skill demands that were coming because of technological progress. And that evolution, actually, so in the US, was very much ahead of the other sort of developed nations at that time, although they've since caught up. So if you look at the high school enrollment rate for kids between 15 to 19 years old in 1955, for the US, that was about 80%. That's this line here. And if you look at other developed countries, so Austria, the Netherlands, Luxembourg, Germany, et cetera, you know, at best, and that's adding together not just general high school, but very generously also full-time technical and part-time technical education, these countries were lagging by huge amounts. And they were still lagging, actually, in the 70s or even 80s for some of these countries. So that's a very prominent example of how our institutions, your institutions, acted to deal with these changing labor market demands and conditions. So the US high school movement. Another example of that is, of course, just redistribution of income, right? So for many countries, so this is a set of developed countries, if we look at inequality, so this is a Gini coefficient, which is a measure of inequality. All you need to know is if it's closer to 1, it's more unequal. If it's 0, it's perfectly equal, meaning everyone earns the same amount. So here's the inequality for these countries before any taxes or transfers have occurred, right? So just market inequality. And we see that in all these countries, these taxes and transfers act to substantially reduce the amount of inequality that occurs in reality, right, after these systems happen. And of course, different countries redistribute different amounts, right, even if they have the same underlying amount of market inequality. So I'm from the Netherlands. The Netherlands and the US actually have the same amount of market inequality. We have the same technology as well, right? So really, it's institutions that make up any difference in inequality here, and those are, of course, political choices. So we vote and decide what, as a society, we want to do. But all these societies have, to some extent, voted and decided to redistribute, right? To redistribute income, to share whatever gains there are more equally among citizens. This is also where the challenge comes in, though, is that this type of institutions, and that goes for the high school movement, that goes for redistribution, are in no way automatic, right? They need to be put into place, they need to be maintained, there needs to be political will. And if you look at, for example, the evolution of US inequality measured by the Gini coefficient, starting at sort of the start of the digital revolution in 1980, up to more or less now, we do see that these taxes and transfers have acted to decrease inequality throughout, but there has been an increased widening, right? So there's nothing automatic about that sort of institutional response to somehow magically compensate these changes, right? So that's what the sort of downside is of that we're voting, is that we also have to take responsibility and make these things happen. There's nothing automatic about how these markets work that everyone will benefit equally from these changes, as I've shown. Here's another sort of challenge, I think, which is in many countries an issue, which is a political polarization. So people seem to be drifting apart in terms of their political preferences of how they think society should be organized. And this is showing in 1994, 2004, and 2014. This is a distribution of political preferences among Republicans. So what this is showing is, of course, if you look at the distribution, most Republicans are conservative. That's why they're Republicans. But in 1994, the median Democrat was only 64% of Republicans were more conservative than the median Democrat. So they were not all that far away from each other. But that has increased to about 92% of Republicans in 2014. So that's really sort of diverging political perspectives, which all else equal, you think makes it more difficult to come together and agree on what should be done to deal with any societal challenges that occur, including the ones coming from automation, right? And of course, the flip side is the same for the Democrats. So here you have the preference of political preferences of Democrats, which of course liberal leaning. But in 1994, the median Republican here, comparing that to Democrats, 70% of Democrats were more liberal than the median Republican, but that's increased to virtually all of them in 2014. So that's really showing that this political polarization phenomenon has taken hold. And some commentators and researchers think that that's also related potentially to economic shocks. So that's sort of the other side of the coin is if some of these economic impacts are perhaps very uneven and not all that well absorbed or spread across society, shared across society, then you can have that sort of people who have been hit harder will express their political discontent. Right? And this is showing for a trade shock, which is the entry of China to the WTO, which has nothing to do with technology, but it's similar in the sense that we think trade raises incomes. As consumers, our prices become cheaper, we're better off, but some jobs are hit or some regions are hit pretty hard, right? And that creates losers and winners. Not everyone is made better off. And this is simulating what US Congress would look like had in the absence of this trade shock, and that shows that there would be much more moderate politicians in Congress as a result in the absence of that shock. And other researchers are also relating this to the introduction of robots, suggesting both in the US and in Europe that places that have been more exposed to automation have also swung more towards a sort of extreme voting. All right. So that's my final point, is that because we vote, we don't just passively undergo those technological transformations. We can shape them. We can ensure that people share in these benefits. But it's in no way automatic that will happen. And there needs to be some political will and coming together for that to be organized. And the sort of problem is that those economic shocks themselves may make that difficult if they're not well absorbed. So just to summarize, are we entering this robocalyptic scenario? No, when it comes to humans becoming obsolete in the labor market, we don't see that because people are not one-trick ponies and because people have income. So those mechanisms have acted to compensate any direct automation, any job losses coming from automation. But I think we can, use that spare worrying capacity about the robocalypse. We can reallocate that to worrying about distributional issues and the political challenges that also come with that, which I think are very real. So thank you.
So Professor Salomons will be happy to answer some questions. We have a microphone, and please wait until you have a microphone to ask your question because we are recording this and we want to hear your question as well as your answer. So if you have a question, raise your hand.
Thank you.
Hi, thank you. So my question is, I guess, a concern about the technologies you focused on. So looking at a lot of sort of mechanical labor. What do you make of the fact that, say, self-driving cars are becoming more prominent and the cognitive capacities of our machines are becoming, equivalent to human beings? So they can drive cars. I noticed that, for example, I don't recall seeing like transportation, and that makes up a large share in the U.S. of the labor market. The CGP Gray video discusses that as an example of a place where we're going to see a big labor hit if self-driving cars become prominent in the economy, and for safety and economic reasons, it's very likely that they will be adopted at least by larger corporations. So I was wondering, how does the developments in our cognitive machines affect or impact the conclusions you draw from this data?
Yeah, absolutely. That's a very good question. I completely agree with you that driverless cars and these technologies, are likely to take off. We don't know exactly when or how fast, and they're likely to have a big impact on the transport sector, right? So there's likely to be big automation, human replacement. Of course, that's really all that's different from the sort of technologies we've seen so far is that it's affecting a different kind of job. But the mechanisms that humans adapt what we do in response to those technologies and that will create demand responses are still in place, unless you think that we've run out of ideas and we've run out of, we're sort of, there's a limit to human creativity, which just because I can't imagine it, I wouldn't want to postulate that. So I think we haven't seen that yet. I don't think we will. And also that we will sort of say, okay, we're kind of comfortable with our current living standards. We're good. We don't need to spend more. Also not any evidence to suggest that. So I think where your point is this will be disruptive. Completely agree. This will be disruptive in a different way, in the sense it will affect different jobs than the sort of, let's say, industrial robots have affected. But the underlying mechanism is the same, right? So if you take your argument, and if you looked at what people were doing in 1880, before agricultural mechanization, you could make the same story and say, look, now all these agricultural machines are coming in. We're no longer going to need people for agriculture. We're out, right? There's nothing we're going to be doing anymore. But that's not what happened. So this is the same argument. And one reason is because people adapted, right? So that's a huge part of it. Again, as I said, take the labor force from back then, transplant them into now, most of them would be pretty useless. So that's something that I think is exactly the same underlying mechanism. But I completely agree with you. This can be very disruptive. And I think one of the big sort of underlying what makes it disruptive is also the pace at which it happens, right? If you imagine that between today and next week, all driving is going to be replaced by fully automated driverless cars, that's a completely different story than sort of the gradual sort of transition to driverless cars, which we're already a little bit seeing, right, with sort of the technologies that are even in normal cars now have already taken over quite a bit of the things that people do, but we still need people there, right? So depending on the pace of change, I think that will be a big factor in terms of how disruptive it will be, but I don't think the underlying compensating mechanisms are all that different. And what's sort of ironic is that on the one hand, people are afraid that we're becoming so productive that we're automating ourselves out of jobs, right? It's just incredible. On the other hand, there are people saying we're not coming up with new ideas fast enough, right? We're not becoming productive fast enough. We're stagnating. Those things can't both be true at the same time, right? So that's the good news. And even better news is they can both be false, right? They can be somewhere in the middle where we're coming up with new ideas, but not at such a crazy disruptive pace that it will immediately obliterate an entire sector, for example. But I do agree with you that this is on the horizon. How fast will it happen? It will certainly be disruptive to people who are currently, as their main job, driving trucks, for example. But will it make human labor obsolete? I don't think so.
Thanks for the talk. It was pretty good. Really enjoyed it.
High praise.
I was actually one clarity to make and then two questions.
Mm-hmm.
So I saw your plot about the 95 percentile people getting the wage or the income difference getting really high, and one of the reasons was being that the skill is biased for those people, right? And so what do you just clarifying that what were the skills? Were they like actual technical skills, or was it more of I would say like a company or business skills, or because 95 percentile I feel like is really high income, and I don't see actual engineers or technical people who are getting more, but that's where real development is coming in AI and stuff, making that much money and getting the difference that big. So where was that, like what's the percentile difference coming in from where?
Yeah, that's a very good point. So I probably went over a bit quickly, but a lot of the increase in this, up to this percent, is coming from increases in returns to college. So increases in returns to education, also to experience. So these are really broad sort of problem solving, critical thinking, creativity type skills. And if you really dig into what makes these people more complementary to new technologies, I think in part it's the ability to adapt. I mean, of course, it's also in part the things that, that cannot yet be automated, right? And work that's looked specifically into skills has found that the most value in the labor market currently is a combination of technical and social skills, say managing teams, but also being able to do abstract reasoning, problem solving, and sort of quantitative analysis together with social skills. But also independently, technical skills and social skills have increasing returns. So really this, if you look at, the reason I look at the 95%, if you look at the very, very top, there's some other things also going on there, right? So superstar effects, which some people argue are also related to technology in the sense that you can reach bigger markets, maybe also partially related to globalization. But most of the, say, inequality among the 99%, let's call it, is coming from increases in returns to schooling. And that's why economists have thought of these technologies being skill biased, generally. Yeah. So it's not just a phenomenon of the 95, if that's what you mean. So it's that graph I showed with the increase in the return to college relative to high school, that's really a big underlying factor.
The second question I have is about the demand that is the plot where the demand increases for a little bit and then gradually it starts dropping, right? So right now when you see getting more automation, then there's like creation of jobs. How long do you think that will last before we actually hit the period where like, okay, we kind of actually, there's some decline of jobs now?
Yeah, that's a very good question. So I think that's the part of the demand response that occurs within industries, right? So that's saying, so that graph is for textiles. So that was really saying, in 1800, textile production was so unproductive, it was prohibitively expensive to own lots of clothes, right? So people had like one formal suit, and that sort of they washed stuff a lot. But as textiles became more production became more productive as a result of automation, people started basically buying a lot more clothes, but also using textiles for draperies, for carpets, all these other purposes where it became now profitable to do, and that created a huge surge in demand, which is large enough to increase employment. But then at some point, the sort of highest value usages of textile start to become exhausted. You still buy more textiles if it becomes cheaper, but there's some limit to that. That's what you're describing, right? So that's what you tend to see. And so the person who analyzed that, Jim Besson, has shown that for a number of industries, also automotive, steel, so that's a sort of repeating pattern. Now, why does that still matter despite eventually hitting some decline? That means that it's not once we start automating things, we immediately see this huge drop, right? So there's some compensating mechanism. And then together with David Otter, for example, we've looked at these demand effects that occur between industries. So the idea being, if you previously spent a big part of your budget on textiles because they were expensive, now they're becoming cheap, you buy some more textiles, but mostly you also buy more of everything else. And that creates employment everywhere. And that effect is very robust and positive and large enough to actually overcompensate what's happening within those individual industries. So that's really where the second part of the demand effect comes in. Yeah.
Hi, thank you. Kind of related to the compass theme for this year of religion, in addition to the economic aspect, certainly, of automation, there's also the aspect of work, like the dignity of work, the idea that human beings, it's good for us psychologically, spiritually, to be able to go out and work. How do you see technological change affecting that, especially this, like the barbell effect?
Right, I think that's an excellent question. So I think as economists, we think of work as, something we don't like to do, but, they pay us for it, so all right, But this is absolutely true that work is a big part of identity, of social life, of how people are part of the community, etc. So the absence of work is detrimental. So if you also see these economic shocks, these regions that are hit, for example, very hard by import competition from China, there's real suffering there. So that makes these sort of transition impacts very important, firstly. So not just because people have loss of income, but because they have loss of identity, loss of self-esteem, and especially if this is within a community, sort of multiplies. But so I think the sort of short answer to that is the sort of future of work requires the presence of work. So work is an essential part of what we do, but the nature of it has changed over time. Now, I do think that's why this barbell economy, as you mentioned, is important, because there are still a lot of jobs that aren't getting all that many rewards financially, but perhaps also in a broader sense, sort of in terms of respect or in terms of standing in the economy. So I do think that's something that is maybe not all that easy to think about in that sense, but I think a sort of increasing divide between people who are doing very high-skilled abstract jobs and people who are doing very low-skilled jobs could also, in that sense, sort of socially be problematic, right? So that's sort of why people are concerned about the decline of the middle class, is I think because of that. They see the middle class as sort of a cohesion between the different parts in your society, and a decline there could be in that sense problematic. So, but yeah, I think the main underlying point, and that's also why I think people are really worried about this robotic apocalypse, is because jobs are such an integral part of what we do. So the sort of idea that also was alluded to before, so what if we're living in this singularity, this technological singularity where computers and machines dominate in every single domain, right? There's nothing left for us to do. Now, talking to people who develop these things, they don't really think this is possible, but maybe they're grossly underestimating themselves and this is possible. Then still, I think, if you look at purely an income perspective, you would think, well, then we're just living in an economy of abundance, and then it matters who owns all this amazing technology, right? So if we all have our own little personal robot that we can send out to do things for us that we don't like to do so much, that's a very different economy than where we have all that amazing technology, but it's owned all by one person, right? So in that sense, I think that's sort of what you're alluding to, is what is, in the end, sort of ownership of performing these tasks, and part of that could be who owns these technologies, who owns this capital. So Yeah, I think that's an excellent point. I don't know if I've answered it, but.
Thank you.
I read a book called The Silence Revolution. It talks about once as countries' economy situation related to the group of people that in the country about their political tendency. And I think if we apply this on the class, and then explain why this political is diverging, political tendency is diverging based on the classes. But I want to point out there's a problem. I think when technology or horses, they are capital as well, but they can generate capital as well. But human is different. Human take because human have income, so they will take at least part of the capital for their own. But as the development of technologies, so the diverging of distribution will keep going, and I think the diverging of classes will keep going. I know this is kind of pessimistic, but could you please give me some good news?
Oh, wow, no pressure. No, I mean, so, you should always be careful extrapolating things into the future, right? So we can now say, look, we now know what's happening to technology. We're just going to extrapolate that indefinitely, and we know where we're going to end up. That's usually not the case. And one reason that's not the case is because also the nature of these technologies is shifting, right? So the type of technology I've talked about mostly and that we've seen so far are these rules-based technologies, right? This if-then statements. But really, machine learning is sort of a way around that in the sense that it's kind of a statistical best guess to a problem, not a closed-form solution, if you will. So it's sort of, in that sense, perhaps one could argue, this is extremely speculative, but perhaps more innately complementary to human judgment and human input than these things that are fully automated or not automated at all, right? So you can imagine also that perhaps there are new wave technologies coming that are, going to aid in human judgment, but driverless cars are a good example. Maybe there will still be some rule there place there for humans to intervene and to judge and to aid in the prediction of what these technologies are doing. This sort of somewhat silly, but examples of these game shows, etc. There's this chess computers beat human grandmasters extremely easily, right? But together, humans and machines do better than any single machine, right? So these complementarities, I think, are likely to continue. So that's why I'm not so pessimistic. So I think if we were like horses and we have a fixed set of things we can do and come up with, I would be extremely worried. But given that we adjust and move into things that are complementary to these new technologies, I think that there's a future for humans. And these, if you look at the technologies that are coming, it's not at all clear to me that those would be completely substituting what we're doing, even given our current, let's say, capabilities, right? So I don't know if that's made you more optimistic, but I think it's what we can learn from what's happened so far. What I've tried to do is sort of talk about the general principles, I think, of how these impacts work, which is people adjust their demand responses, but of course the types of technologies or the nature of these technologies or the types of skills they complement or replace can be very different, and that's, I think, also part of the concern is technologies could be moving in on a set of jobs that we've currently really been shielded from this type of impact, right? So that doesn't make the overall outcome in terms of total employment numbers different, but it could really shift, which jobs are impacted, which regions, who are impacted. So I think that's the real sort of uncertainty that we have, and but I'm not pessimistic about the Robocalypse arriving in that sense. So, yeah.
Hi, I actually work in one of those jobs that we've thought for years was shielded. I'm a teacher, and teaching is becoming more and more a matter of technology, and technology in public schools being used to actually replace teachers and shrink the number of people working in it. So what I want to know, so you're looking at data from, it goes to about 1980, so now there's been 2 generations since then. To increase my optimism about this, are there any examples of industries or jobs where it looked like technology was going to replace people and it turned out that people actually did it better, so technology shrank and the human component increased?
Well, if it's a good technology, technology wouldn't shrink, right? So, but there are many examples of human inputs staying constant or increasing, like these bank tellers or paralegals, or I think teachers as well. Is there all that much teaching automation going on? And I should get on top of that because I teach and it's so much work. But is it?
Yes, I heard that part of it. I understood what you're saying about the bank tellers. What I want to know is if there are industries where it was envisioned 2 generations ago that technology would make people replaceable, but then it turned out that the technology was not a good substitute, and that in fact the employment component increased. Because again, right now teachers are in public school systems, and especially as the electronic schools are growing, it is an aim to shrink the number of people who actually become teachers. What I'm wanting to know is there's an example of where purely economic, not moral, not spiritual pressures said actually this isn't going to work.
Oh, that's very interesting. So that's sort of an endogenous adoption story, right? So do we basically only replace people when we need them, right? When we need them to be replaced, or when we don't have enough people to fulfill the job needs, right? I mean, your first part of the question is, have there been incorrect predictions about the state of technology? Sure, especially by economists, we're great at getting it wrong. So this is wasn't it people predicted flying cars and then they were disappointed that we got 140 characters, right? So we definitely I think some revolutions that were predicted never happened, and then surely those things kept being very labor intensive. But I actually have some evidence on maybe what you're getting at, which is to say, to what extent is this adoption actually endogenous to the state of, let's say, the labor market? And this is showing, again, for robots, how there's quite a lot of differences across countries in the number of robots per, 1,000 workers, again. And part of that can be explained by how much aging there is in those societies. So in countries where there's a lot of aging, there's much more demand for these robots, because there's just a shortage of labor. There's just really problems getting people to, for example, do all the healthcare that's required in some of these societies, including Singapore, South Korea, Germany. I think Japan should be in there as well. So certainly, I mean, the sort of incredible potential of these technologies to also help address those labor shortages coming, for example, from aging and other sorts of demographic headwinds or shortages of workers or jobs that workers don't want to do, right? There's also a lot of dangerous, dirty jobs that have been automated, which is probably great that, if you think of the sort of work that was being done 150 years ago, a lot of that was probably certainly physically much more taxing, and in that sense you can see that as a good thing as well, right? That what we've moved into is probably better in that sense. I'm not sure if that addresses your question about, I think your first part of your question is essentially saying, has this sort of increased technological adoption ever been sort of predicted to be really fast and it turned out to be much slower? I think yes, all the time, right? So we're still seeing a lot of predictions where people saying, look, driverless cars are here tomorrow, the singularity is upon us, we're being, but if you actually look at some of these technologies, it can be decidedly unimpressive. If the most exciting thing that happened is a robot opening a door, I think that's not all that transformative compared to what you would expect would be needed to really say we're going to wipe out in a very short order a very big part of the things that people are doing now. So I think actually if you talk to people who develop these technologies, they tend to be much more sort of reserved in terms of, they say there's a lot of potential, but how fast is it really going? Well, we still have a lot of problems with all these things. So we're still going to need people to work with it, or we're going to need people for a long time anyway, because we really haven't fixed this big issue of how to solve this problem that currently people are doing. And so I think that's certainly the case. And probably, I would say on average, the reporting on technology is probably very overhyped in the sense of, saying, oh, look at all this cool stuff. But, there's still a lot that technology can't do and probably will continue to not be able to do for a long time. So that gives us time to adjust, right? So that's, again, getting back to the point that, all else equal, the faster these transformations are, the better in terms of productivity growth, but the more painful the adjustment from a human worker perspective can also be. So, but yeah, I think technologies are over-predicted, in terms of their capabilities all the time. So, yeah.
Hi.
I'm gonna ask another scenario about our automation. So many people believe that the technological singularity will happen within 20 or 30 years. However, many economists believe that you will be slowed down of the speed of technological advance, like the Robert Gordon
Yeah.
in Northwestern University. And I found that their arguments are also very strong. And according to them, we don't need to worry about Robocalypse because there will be no technological advance. On the other hand, sorry. My point is, what do you think about this scenario? So there are another extreme scenario. You don't need to worry about that because there will be no technological advance, very fast advance. So in fact, there are many boom and bust in AI field, especially from as early as 1960s. So many people believe that this is another boom and bust. So machine learning cannot revolutionize our economy, where they may improve our search machine, but it may not be able to revolutionize entire economy. So what do you think about this scenario and this scenario?
No, it's a very good point. I mean, I was sort of alluding to before is that people have there's these two competing concerns, right? The one that I've sort of spent most time talking about is, are we automating ourselves out of jobs? But certainly there are people like Bob Gordon and others that are talking about secular stagnation. We're running out of ideas. Productivity growth has been very disappointing. There's nothing all that impressive on the horizon. What's up with that? So I think if you look at productivity statistics, there's evidence to support this. So productivity has slowed down over time. Some people argue this is a figment of the statistics, that the sort of quality improvements that some of these new technologies are engendering are hard to measure, but that's possible. But putting that aside, it would be a concern if there were a sort of secular slowdown. And some people argue this is also demographic. So Bob Gordon also says it can be coming from population aging, right? So, that would be a concern because the main increase in our living standards comes from technological progress, and especially given that the labor share is declining, as I said. So if there's very little productivity growth, as we've had in the 2000s, for example, very little productivity growth, and a declining share of that additional income is coming to labor, then basically wages are stagnating, right? So that's a concern. So then we're basically standing still, and most people think growth is a good thing, and income growth is a good thing. So that's certainly a concern. And exactly as you mentioned, so some people see machine learning as a sort of new general purpose technology, meaning something that's going to sort of transform across many different sectors what we do, right? Other people are more pessimistic about that. I think time will tell. But I think most people, at least everyone I've ever talked to, agrees that productivity growth is a good thing, right? It increases our income. So we would certainly be very concerned if there were not enough of that occurring. And part of that is, of course, also investment in the complementary skills and in research and in producing that technology. And I think the demographic sort of headwinds people have mentioned, which could in part also be solved by some of these technologies potentially making labor more productive again, right? So, but I think that's what certainly is a concern, and hopefully something like machine learning can help address, or other types of technologies kind of hard to predict. But there are also people like Eric Brynjolfsson who say we're sort of on the cusp of the next big thing. It's just coming with a lag, right? It's both hard to measure, and the sort of initial stages of the technologies are not all that productive. There's still a lot of fiddling around, but the next sort of big thing is coming. So, I mean, we'll be alive to hopefully see it.
What do you think? So do you agree the optimistic people? Do you agree the optimistic people or the pessimistic people?
Oh, well, I don't believe, so I'm not in either extreme, I think. So I don't believe in this mass, singularity. I think that the people who are working on these technologies, I believe them, they know what they're doing, don't seem to believe this is a realistic scenario. Even if it were, as I mentioned before, it seems to me, again, to be, then we have living in an economy of abundance. And it's, again, a distributional issue. But, there is certainly the statistics support the idea that there's been a slowdown in productivity growth, and there's certainly been, relatively stagnant wages, especially at the bottom as a result of that. So that's a very big concern. So I would hope that productivity growth speeds up again. I think there's something to the measurement issue as well. So I do think that some of these advantages are difficult to measure. So I know there are research initiatives trying to do better at measuring these sort of productivity enhancements. But I'm not pessimistic in the sense that I don't think there's all that much evidence to support that we're running out of ideas. Maybe, maybe they're becoming hard to find, and there's some work to suggest that it takes more inputs to find them. So I think what that requires is an effort to put in resources to come up with new ideas and to do research. That would be my hope there, that we manage to do that as societies.
Thank you. I wonder if you could say more about your case for why you don't think things are different this time. So here's a kind of relatively naive train of thought that I have about this. It's easy to understand why the development of ATMs and assembly line robots would not eliminate all human jobs. It would merely displace humans from certain lines of work and force them into other lines of work. Because one of the capabilities that humans can do, and one of the things that people used to get paid for doing, is physical manipulations of things, right? Physically handing over some money or physically assembling a bunch of stuff. And it's easy to see that there are many jobs that a human being could do that don't involve physically handing something over. Namely, jobs involving thinking about stuff. There are many, many jobs involving thinking that don't involve any kind of physical manipulation. And so it's not surprising that automating the kind of physical manipulation of things would not have this apocalyptic effect. But now consider the possibility that thinking is going to be automated. So consider the possibility, and I know that maybe you're skeptical that this could happen, but suppose for the sake of the argument that 50 years from now there will be human-level artificial intelligence. And I'm not just referring to AI that can perform at human levels within relatively narrow domains. We already have that, but imagine that there will be general human-level AI. Okay. Well, then you have a situation in which there's going to be this AI, which presumably is easy to reproduce and cheap to maintain, and you don't have to pay as much, right? That is capable of thinking in all of the relevant domains as well as human beings are. Okay? So now we're thinking about a scenario in which we can more cheaply do all of the jobs that involve thinking by not using human beings. It's less obvious to me that that wouldn't be disruptive across all industries. I mean, I can still imagine certain industries in which general human-level AI would not do as well as humans. So if you have an industry in which it matters very much, there's a human touch, palliative care maybe, or elder care, it matters a lot. It's not good enough to have a super smart robot with a metallic hand. You need a warm, empathetic human being to be there, right? So I can easily imagine that there will still be industries in which it would be sensible to employ humans, but there seem to be relatively few such industries. And so I just worry that once the machines become capable of thinking in all of the relevant domains as well as we can, that will be a significantly different disruption than the disruption that occurred when physical manipulations of things were automated.
Certainly that's different. So, I mean, this time is different, that's always true, right? Every time is different. So the question is, how is it different? Will it affect different jobs? Certainly. Will it still be disruptive? Certainly, right? Will it be disruptive in different ways in the sense that, jobs that are now shielded will then be impacted, like a lot of the thinking work that you're describing, quite possibly. But what is underlying your story of that there will be nothing left for humans to do is really the assumption that we'll run out of ideas of creativity, of new things to do, that we currently can't imagine any more than people in 1880 could imagine that we're today working as software engineers, cybersecurity specialists, and dog psychologists, right? So, I mean, this is also, you can't fault people for not right now being able to think up what's going to happen, what we're going to be doing in 200 years from now. That would be a sort of constraint that I don't think is realistic. If I were from 1800, I couldn't have invented today what we're doing today, I think, any more than we can today in the future. So really the underlying premise is we're gonna become one-trick ponies. That's really what you're saying, right? We can only do the things we're doing now. Technology's encroaching on those things. That's it, we're out, right? So I don't think that's any historical evidence to support that. I think there will be big disruption, right? So this will be definitely an adjustment in the same way that the processes that we've seen before are an adjustment, right? So what the sort of transition from agriculture to industry and then from industry to service, I mean, those are also huge adjustments. And a lot of the jobs that we're doing today are totally unimaginable and unattainable to people from the past, right? So I think, again, you know, and sort of even entertaining the notion, this singularity that you mentioned, is sort of in that sense, doesn't seem to be evidence to support it, but also still assumes that we won't come up with other things, which we have so far, which tend to be labor using. So the argument there that people have made is, you know, we automate the things that we know how to do, then we come up with new things to do, and by their very nature, we haven't yet figured out how to automate them. So that's going to take some time, right? Even if we can eventually do it. So, and then we're going to add more stuff that we hadn't thought of doing before, in part aided by those new technologies, right? A lot of the goods and services we have are sort of enabled by what we've thought up because of these new amazing technologies we have that we didn't have before. So I'm not pessimistic about that. I mean, if you really want to, you know, again, in the extreme singularity scenario, then really you are again in a situation where if you're saying by definition there will be nothing left for humans, then that will by definition be true, right? But if you're allowing humans to adapt, then that's not clear to me that that would happen. In your scenario, if that's by definition true, then I guess all we can hope is that they'll want to keep us as pets and that we're cute, right? That's it. So
no, so I didn't mean for it to be true by definition. And just to be clear, I want to grant that there will, of course, be some number of new jobs developed that we're not in a position to imagine now. But I mean, the real issue is a quantitative issue. How many people will be employed in these new jobs that will be developed in the future that we can't imagine now? And there are certain ways of filling in the details of this scenario. I mean, just imagine that there's widespread automation of jobs that involve thinking, and that the wealth is not appropriately redistributed. And so you have a situation in which you have a small number of ultra-rich people who have a lot of resources, and the rest of us are impoverished, right? Now, I can, of course, I would expect these ultra-rich people to come up with ever more elaborate ways in which they can pay people to do things that they don't want to do, but there's going to be a limit to how many servants these people can have.
So there's also the demand response, right, which is my second point. So unless you're thinking these things are fully automated, you have to think that if you're partially automated, part of the things you do are automated, that means you're complemented, right? So I'm a researcher. So you might say I do empirical research that used to be incredibly time consuming. There's very little computing power. It took forever to estimate a regression. Now those things are done in a split second. I'm just sitting there twiddling my thumbs, right? No, I mean, empirical research has boomed incredibly because of these increased capabilities, because it's complementary to what we do, right? So that's the essence of complementarity, and that exists for people because we adjust, right, and take advantage of those things that do part of the things we used to do, and we are the scarce factor that then are in demand, right, that are not abundant. So I completely agree with you that the inequality is a real concern there. That could have perhaps all sorts of long-run adverse consequences. There are some people who have sort of considered overlapping generation models of impoverishment coming from appropriation of the gains of technology by sort of some part of the generation. So that's certainly thinkable, and I think that goes to my final point, which is about humans vote, right? So that's not automatic that this will end up good. So I completely agree with you there. But then that sort of brings me to the concerns that I highlighted, and not the concern of we'll have nothing to do. It's more about who's doing it, you know, where are the gains going, and you know, are we making sure that those negative impacts, which do exist and which can be extremely disruptive, aren't being borne by disproportionately by some people who, you know, will then get little gain and a lot of pain, right? So I think that's the real concern. I think we agree on the concern, but I wouldn't call it Robocalypse in the sense that it's not making people obsolete as such. I think, yeah.
Well, first, thank you for helping to think rigorously about something I usually just respond to with panic attacks. have some mental structures to put thoughts through. I think a new question would be, so most of your examples and thinking was about productivity.
Mm-hmm.
Does it change with the economic analysis if it's the production of destruction? So I'm thinking things like the automation of warfare, the automation of criminality. Does that alter the analyses, or is there a body of thought toward, industrialized warfare sucked badly enough? How bad will automated warfare be, and will it change more thoroughly?
Oh, that's an excellent question. I mean, I'm a labor economist, so this is, I think, a sort of ethics of technology question, which is a huge field more, I think, in philosophy, so I should probably hand the mic to the experts here. But for sure, people are very much thinking about these impacts, and I think worrying about these impacts. Certainly, I mean, as a labor economist, I confess to not knowing all that much about it that I would want to, address that too confidently. But certainly, there are a lot of societal challenges coming from technologies that are not related to the labor market impacts. So those can be related to warfare. Those can be related to the use of algorithms in decision making more broadly, say in credit scoring or in other types of markets, right? So certainly, the labor market impact's not the only thing that people are concerned about. And just because we're not worried about massive job loss, perhaps I've managed to convince you, I don't know, but that doesn't mean that we wouldn't be worried about some of these other concerns, right? Ethical concerns, or how much autonomy do we want to give? Look, the driverless car is another example, right? So this recent crash and unfortunate death from this crash by this driverless car, it's unclear what the legal responsibility lies. It's unclear how that would change. Maybe people aren't really good at interacting with these machines and algorithms, and they give them too much responsibility, and they sort of go hands off, well, the machine knows best, and maybe it doesn't, right? So I think those are also real concerns that people, better people than I, are thinking about beyond the labor market impact, certainly, yes.
First of all, I thought this was an excellent introduction to the topic, so
Thank you.
I won't talk about the singularity here. But I do want to ask more about this demand effect that you've discussed several times. The idea seems to be that when a new level of automation comes to an industry, the cost of the good or service that's under discussion will drop dramatically, demand will increase as a result, and thus you can fund possibly even more jobs than before. But while I can certainly see temporary effects occurring when an industry is changing very rapidly and there's only a limited amount of infrastructure for the newest technological paradigm in place, eventually, no matter how much demand there is, it is going to be met, I would assume, by those who can meet that demand with the most efficient process available. It's all going to be met by the efficient, highly automated process. So the only jobs which will be supported in the limit are those that are directly a part of that process, which are probably going to be extremely high skill as time goes on. So are you saying that this is more than a temporary effect, and if so, how?
No, I think that's exactly right. So this is the sort of illustrates the potentially temporary nature of that, right? Which you can sort of has been hypothesized to be because the most high value usages of those goods are exhausted first, right? You use steel. This is for steel. I've shown it before for textiles. There's, at some point, you're not going to, code everything in steel, right? At some point, we're running out of the highest value usage of them. So the demand response to a given price decline is going to weaken over time, right? So that's only part of the demand response. So it is important because it means that the decline in labor demand isn't one for one, right? Because there is a demand response. But a bigger part of that demand response comes from increases in demand across industry. So if you spend a lot of your income on steel or textiles or whatever is becoming more productive, you're freeing up income, and people tend to spend the income they make. That's what we do, and that's what this analysis shows. These demand effects operate across industries. So, people save, take a very silly example, buying a fridge, right, may have been taking up a big part of your budget in the past, but those things are becoming cheaper to produce, right? So in real terms, your income is increasing. That additional income you get, you spend on everything else, right? And that's what happens with these between industry linkages. So if you just look at the industry where the automation is taking place, you're getting a warped view of what's happening to total employment because employment is increasing everywhere in the economy. There's not just a demand response within that industry. So that's what's driving actually the overall increase most. I mean, people don't just when more income becomes available to them because the prices of certain goods decline, buy more of those goods, they buy more of everything, right? And that's, so you have to account for those increases in employment as well. Now, the point you're making about who meets this demand is extremely interesting, and it goes to a literature looking at what's happening at the firm level. And it is the case that there's an increased reallocation of product demand to the most high productive firms, the larger firms, which happen to also be more capital intensive. And it's been shown that that's driving part of the decline of the labor share is just a compositional shift towards those more capital intensive, automation intensive, if you will, firms. And it's been hypothesized could be part of the technology story, could also be because of competition pressures from globalization. But that's that's part of this compositional shift that tends to increase inequality through declining labor share. So that's certainly true. But the reason we don't see declining net employment is not only from these demand effects within industries, which do tend to exhaust at some point, but also between industries, right? And then, of course, new things get added, and there's demand for those. But all else equal, you would expect if demand for everything we want to consume is very saturated, you would expect less of a demand response coming from that. The overall demand response is still alive, only if you were to assume that people no longer like to spend, can you sort of say, okay, that's going to be shut down, right? So if you think, at some point people are going to be like, we're so rich now, we don't need extra stuff, all these new goods and services, meh, no thanks, then you would be worried that that demand response falters and you no longer see that compensating effect that we estimate there. Pretty robust evidence that people like new stuff and tend to buy new stuff, and this is why I'm, pretty optimistic about that demand response. But certainly that within industry reallocation you're highlighting is also occurring, and that can have effects for inequality. So that's a very good point. We're going to run out of time, right? Yeah.
Before we thank our speaker,
thank you so much.
Oh, wait. I have an announcement to make. If you are a student, and that means undergraduate or graduate student, you have an opportunity tomorrow morning to talk with Professor Salomons more in a small group setting at the Kuhn Honors House from 9 to 10 tomorrow morning. If you're interested in doing so, please come up and grab one of these flyers that shows you how to register for that event. That'll happen again from 9 to 10. Is that going to stay there? We'll put it right here. From 9 to 10 tomorrow morning at the Kuhn Honors House. So please join me in thanking Professor Salomons.